This is September 2009. Yeah, September 2009, question number 1. Yeah. So which means if it's question number 1 on any exam, you want to do it well so that you get a booster, right? So this September 2009 CT6, consider the stationary autoregressive process, okay? The AR process of order 1 given by this thing here. Okay, great. Okay, the AR process of order 1 given by yt is 2 alpha yt minus 1 plus zt. They tell me that modulus of alpha is less than 0.5. Okay. It may help, it will help in your solution to this. The modulus of alpha is less than 0.5. That means the size of alpha, right, is smaller than a half. So maybe 1/4, things like that, right? And zt is your white noise, mean zero invariance sigma squared. For flavor, they're using zt this time for your white noise. This question, right, must be careful. Express yt in this form, right? Let me look at it. Yt in the form, yt equals summation, j going from 0 to infinity, okay, aj zt minus j. And hence, or otherwise, find an expression for the variance in terms of alpha and sigma. Look, keep an eye on the marks, right? It's 4 points. So it cannot be so complicated, right? Now, this thing here, this exam, something similar is worked out in your readings. Okay, not exactly the same thing, somewhat like this. They've given you all the working, the IFoA in its readings, plus a lot of explanation is given by the ACTET. So go and look at it, right? Look for those things. Let me write something else that I've, okay, let me just write a few things here. This one here will be 1 minus 2 alpha b. Okay, let me use the backward shift operator, right? Is zt. So yt will be equals to 1 minus 2 alpha b raised to -1 zt. Okay, so I can write yt as equals to 1 plus 2 alpha b plus 2 alpha b squared, okay, plus 2 alpha b cube, okay, dot zt. Let me stop there for a minute, okay. You can also follow my reasoning there, and I've given you an answer there, okay, so you can do that yourself. One of the books that I was looking at has given this approach, which I think is pretty easy to handle as well. So I thought I'll write that down for you here. You can see it straight away, right? Okay, this line here, same as this, right? I just move this to the left-hand side, so I can write this as yt minus 2 alpha yt minus 1, correct? Equals to zt. So using the, what do you call it? Using the backward shift operator, I can write it as 1 minus 2 alpha b, okay, 1 minus 2 alpha b times yt equals to zt, right? So if I move the 1 minus 2 alpha b to the right hand side, then I must write it as yt equals to 1 minus 2 alpha b all raised to -1 zt. This is an elaborate example in your reading. So look it up, right? That's why I thought I'll write it here. Okay. So when you open this up using your, what's the word for it? Your binomial expansion. Yeah. Using a binomial expansion, which we learned it long ago. It's also given in your formula book. You can do that. You'll get 1 plus 2 alpha b plus 2 alpha b whole thing squared plus 2 alpha b whole thing q all the way dot and zt. So basically, this is one way of looking at it. And when you clean this up, you will actually get your answer. Okay. Okay. Not so. I repeat, right? You can already see this. Let me tell you again, right? You can already see this here. Okay. So just relax a little bit, look at it, and see whether you can catch on straight away, right? That 1 plus 2 alpha b plus 2 alpha b squared, blah, blah, and then that's all in brackets multiplied by zt, and you can see that's the same thing. So, okay, so let me just move the screen up a little bit, yeah. So you can see what did I write, right? I wrote this, okay. I started with this, okay. I'm not going to erase this, right? I started with this, folks, and I went here. This is my question. And then you can see what I've done here. I have 2 alpha, and then I have yt minus 1, right? If this yt minus 1 will be 2 alpha yt minus 2 plus zt minus 1, correct? Yeah, that's all I've done here. Plugged it in. You know what? This is the way this is the idea that they're presented also in your CMP, right? In your readings. They ask you to use the recursive approach. They've also done this. So please look both up, right? So I've done it here for you. And then, I've cleaned this up a little bit. I've obtained here. And then it's yt minus 2. Do the same thing. Yt minus 2 will be yt minus 3 plus zt minus 2. Do the same thing and see what happens, right? You clean this up. Yeah, you clean all these things up and you'll get this thing here. Look, I'm not skipping any line. From here to here is not so bad because you have to draw some conclusions about this. One way to think about this is use this idea, right? As you go to infinity, that thing will disappear because of this alpha thing, right? Because it is between, this alpha here is between 0.5, okay, and negative 0.5. So it's a small number. So as it gets bigger and bigger and bigger, as you go towards infinity, it will tend to 0. So that's one way of thinking about it. Okay, that's one way of thinking about it. And I think now I can erase it, right? If you need, you can pause the video and write these things down. I've just used binomial expansion here. This one I've used some simple ideas to expand and so on, and then I'll get my answer straight away. Okay, so if you run into any trouble, you can always send me a note. Okay, am I done with that? Yeah, they want, okay, let's just move on a little bit and finish this problem. The problem, I think you can finish it yourself. It's not complicated. Okay, so once you're done with that, right, summation from j equal to 0 to infinity, 2 alpha, we are using some index, right? J, 2 alpha to the j, and I have zt minus j. Okay, exactly as they wanted it, right? So good. Then the variance part is easy, right? The variance part you can easily follow. Okay, you can easily follow. Just write your variance thing, move your operator inside, right? Move your operator inside. Just be a bit careful because I'm just using the idea that variance of ax is what? A squared variance of x. Can you see? This 2 alpha thing, 2 alpha j, and you square it, you'll get this. Okay, so please be a bit careful about that, right? And then you have your variance thing. And then you have to go and use your sum to infinity. Okay, your sum to infinity. Remember your geometric series sum to infinity is your sum. Let me write it here. As infinity is a over 1 minus r. We have a plus ar plus ar squared plus and so on. Okay, for r between 1 and minus 1. Correct? This formula. So this part here is easy. I know it's sigma squared. Okay, this part here is what you need to take care of. Okay, this part here is easy, sigma squared. This part is what you need to take care of. So you start from 0, right? So you plug in 0, we have 1. Then next you go to j equals to 1, right? When j equals to 1, we have 2 alpha squared, correct? Then j equals to 2, you have 2 alpha 4, correct? So what is my common ratio here? My common ratio here is 2 alpha squared. There you go. A over 1 minus r, 1 over 1 minus r, and we are done. Don't forget there's a sigma squared here.